we now come to activity 3, which is the system design. Now, just to remind ourselves, in activity 2, we were doing a few things like writing the operational requirements and the enhancements and unexpected conditions. And then we wrote down, or we filled a test plan template with the main things that we do need to test to show that everything is working, including the enhancement. And now we come to activity 3, which is the system design. And again, just read the information that the exam paper will give you. And you're supposed to write the selection and justification of suitable input and output devices, description of the system covering input and output devices and microcontroller connections, and a plan for the program structure. The main things which you can use for this, which we have covered in class, are would be things like pseudocode, a table of the input and output devices, schematics, which is the circuit diagram, and things like a block diagram of what it looks like. Right, so a reminder of the main things that we covered was, one was the circuit diagram, block diagram, pseudocode, and a table of input and output devices. Now, these don't have to be in any particular order, so I'm going to start anyway with the table of input and output devices. Let's have a look again at the example test booklet, the PDF, which is in your Teams resource. And this is what I've put in to remind you of how to fill in the information for activity 3. This is an example of the table which Pearson themselves have given us. So this is a good example, as they say. So to write down the input and output devices, follow a header like this: name of the component, the purpose of this part, the justification, always do justification, a list of whether it is input and output, or even processing. For processing, that's basically the Arduino. You can talk about quantity. This is not such a big deal. And if you want to put any additional information, you can as well. But the main things that that you do need to put in are the name of the component, the purpose, the reason, justification for using the part, and the input, and whether it is input or an output or a processing piece of equipment. So let's do that as a form of a table. So I'm going to insert the table. I'm going to do 4 columns, okay, and I'll just do a few, add in a few here, so that, let me just move it down here, just as an example. Okay, so remember again, if you want to see more details of how to write things, well, look at the example task booklet there. So following the example task booklet, I'm going to name my column. So I would say name of component, the purpose of the component, which is the justification, whether it is input, output, or a processing device. And I'm not going to put in quantity needed. I'll just say I'll put in any comments extra that I want to put. And I probably will not be using this last column for anything unless I think of something. And then you can delete it or remove the column if you think that there's not much that you want to write about that. So for this one, I don't really need a lot of space. I'll just use a narrower column. The main one really is the purpose of the component or the justification. That is where you can get your marks if you do things properly. So if we look at this again, we've got an egg timer with buttons and some way of showing the cooking time remaining, and maybe some kind of a buzzer or a flashing light if you want, but maybe a buzzer is useful, something different to use in your device. So I will start off maybe some push buttons. Okay, some LEDs, and I will say buzzer. I'm going to keep it fairly simple for this one. Now, this is how we fill in the purpose of component. Let's look again. Okay, what are the key things of filling the of justifying the component? Well, one of them is justify, or based on the reason of how you are going to use it. If you explain how you're going to use it, that will be one justification. Another one will be based on why it is a good choice. So you can talk about the function, the prices, or in this case, to give you an example, the buzzer gives a loud noise, which works very well. Buzzers are also cheap. Okay, just for this example, I'm going to add in one more so you can see some points of how I fill it in. Along with the buzzer, I'm going to say I will have a bright strobe light. Now, really, I'm not going to use this for an exam answer, but I'm going to use this as an example to show you something later on. And finally, of course, it will be Arduino Uno. Is it an input? So let's fill in the easier one first. Is it an input or output processing? So this one is an input, the LEDs, because that is for the controller to interact with the outside world. This will be an output. Buzzer is also an output. The bright strobe light will be an output. The Arduino Uno will be a processing component. Right, let's go to the purpose of the justification. So remember again, we justify based on how you're going to use it, and you should actually, if you can, use both ways. Justify it based on why it is a good choice, and that could be on price. Maybe it's easily available, it works very well. So we would say push buttons. So the first one is how you're going to use it. This will be it's method of for the user to control, not to control, but to enter or inform the Arduino of button press. And you can say Arduino, or the Arduino can easily read a push button press. Okay, so that's one reason how you're using it. The other way that you should add in is why are you choosing a push button? And push buttons are easily available, simple to use on circuits, for example, and we can say as well, they are cheap. Okay, comments. I don't have anything I want to comment on it. I'll leave that blank. What shall we say about LEDs? For LEDs, then, we can say the purpose, as in how we are going to use it. This enables the Arduino to inform the user of something. Okay, and the other way of writing the reason, which you should also do, is that LEDs are cheap and easily available. Does that sound familiar? Well, most of the things that we have in the lab will be cheap and easily available. So use that as a reason. Okay, and easily connected to the Arduino. So this reason is probably very close to this, but that's fine. Just fill it in, and that would be an output. Comments? Nope, I have no comments. Or I could say LEDs of different colors. All right, and talking about colors, you can say LEDs are available in different colors. And how is that useful? Which can be used to represent different kinds of information. Next one is a buzzer. Well, firstly, what are we going to use it for? In this case, it is to alert the user that the time is up, that the countdown is over. So you can say buzzer is, sorry, not buzzer, to alert the user of the time, not of the time, that the time has elapsed. And you can say again, buzzers are clearly heard. Remember, this is a timer that is used to time eggs in a very busy kitchen. And this is where it is useful and important to read the client brief and also the, oh, it's not in this document, it's in the other document, to read the client brief where it tells you what the background is, how it is going to be used. So here we can say it's a noisy kitchen. That's what they told us. So we can say buzzers are clearly heard in a noisy environment. Okay, I'm not going to have, there's no comment that I want to put here, so I'll leave that blank. Now the next thing is a bright strobe light. And this is a little bit over the top, but if you put it in, that's also fine. I'm just using this as an example of where the comments will come in handy. And let's do this and you'll see what I mean. So a bright strobe light, I'm going to say as well to alert the user that the time has elapsed as well. And I can say strobe light is easily seen even if the user is not looking at the device, right? And there's no reason why that won't be a use of correct or a fair reason for using it. Now, we don't have a bright strobe light in the lab. How would you show that? Well, I would be able, instead of a strobe light, I would have an LED and make it flash, for example. So in my comments, I'm going to say simulated by an LED. And this is to tell the examiner, well, I don't have a strobe light. I'm going to use an LED to show that it's on. Same thing if you need to use a motor or an actuator or something which we don't have, then it's very easy to describe what you have in mind and then say at the end, simulated by an LED or simulated by a push button switch, so that the examiner knows how you are implementing it for this exam. Now, how do we choose these things? Remember that I gave you homework to actually write down and describe a list of devices, input and output, as well as the control devices. Things like actuators, switches, temperature sensors. Look back at your homework, and this is why you really needed to have done that homework. And so that if they give you something which requires motion, then you know, okay, it is a motion actuator. You can write a little bit about it and say why. So look through that and try and memorize and remember as much as you can about it. We'll end it now with the Arduino. It's a processing device. And why do we use it? Well, how are we going to use it? We'll just make it shorter to control the device, read the inputs, and it will control the output. The device, the timer equipment, I'll put it this way. Okay, so that's an example of what we are going to use it for. That's the justification. The other justification is, why do we choose that? And we can say again, Arduino is cheap and easily available, and has a powerful programming and tool, which is the Arduino IDE. That's the window that you use to do the programming. Okay, has input and output pins that we can control, and has enough memory for this purpose. Okay, we've talked about these things before. Look through your notes and then you will be able to write these things. Remember, you have to do these things from memory, so for your revision, go back and read through what you have done before. So we have filled in the reason, or the list of input and output devices with the comments. All right, let's go back again to the example, and just to remind ourselves why we do it. Justification is always important. That's where you get your marks. And remember to simulate by using LEDs if you don't have the thing or the device available to you for the exam. So for example, there we do not have a tilt switch in the lab. I will simulate it using a slide switch, and that will be very helpful. Okay, and then the other way to write your justification, and if you write both, that will really impress the examiner. You will say it's based on why it is a good choice on function or price, easily available, or if you have to move something, then mechanical actuator is the only way to do it, for example. Next one is the pseudocode. Now, a reminder, I talked about the pseudocode, so we can, that's EUDODE, and the pseudocode is a way to write your basic steps of the programming code without, remember this, without having to get all the semicolons and the brackets correct. So the pseudocode is a way to write out the structure, roughly how you want it to do. It will not be the final thing, but this is a starting way of showing your thinking. And once you have written the pseudocode, it will naturally lead you to start entering the right kind of control structures and all that for the code, for the real code. So in this case, I've got a timer, And remember, we've got to time let the timer let the user set the time from 2, 3, 4, 5, or 6 minutes. So what I can think of is that we will have a button, and maybe this will be okay, we'll talk about the circuit diagram and all that after this. But pseudocode, I will say, while I will say read the button, for example. Button, we give it a different name. Increase time button. Okay, that means I'll read to see if it's pressed. So I will say if it's pressed, or while it is pressed, while increase time button is pressed, what do I want to do? Remember, I will tab it in so it's easier to see. It moves it to the right. I will say the delay the delay set time. So I will call a variable by that name, and then we can use that later on in the programming. So I would say delay set time equals delay set time plus 1. That means while the button is pressed, it will increase it by 1. Okay, so yes, it reminds us as well, the delay set time. I have to set that. I'm going to start it at 2 minutes because it says it has to be 2, 3, 4, 5, or 6 minutes. Right. So while it is pressed, I will do that, and I will read the button again. Okay, so I will read the button to see if it's still pressed, and if it's still pressed, it will go back up here. That means while it is pressed, it will go and will increase it again by another 1. So it becomes from 2, when it's pressed, it becomes 3, then 4, then 5, then 6. Now, of course, your code will make it increase really, really fast. So maybe it's just helpful to make it to delay things a bit. To delay maybe 500 milliseconds. So every half second, or it will pause every half second so that it doesn't run so quickly that it will go up to 6 very quickly. Okay, so now we've got this first loop of while, and then it's going to change the variable from delay set time. We'll increase it from 2 to 3. Okay, I will read the button again, and then I will delay for half a second, and I will check again. So while it is pressed, so if it is still pressed, then I'll increase it again from 3 to 4, or 4 to 5, or 5 to 6. And each time I'll just delay half a second so at least it doesn't happen so quickly that I don't see what's going on. Right, so after this, I know I have my delay set time. Once I have that set time, what can I do? Well, I can, let me just move this to the left so it's easier to see that I've made an indentation or tabulation. Now I've got the value. This delay set time now has the right program time that the user wants. So I can put in a remark so I can see what's going on. Delay set time now has the number of minutes to count down. What can I do now? Well, start counting down. So maybe I'll have another button. I'm going to do, at this point, I'm going to wait until the user presses a start button. Okay, so I'm going to say, I'm going to do while start button is not pressed, and I'll just say at this point do nothing. So we'll just keep doing nothing until it is pressed. Of course, I need to know, I read the start button so I can see what's going on. So at this point, I'm going to say read start button to see if it's pressed or not. So while it is not pressed, what will I do? Well, I'm going to keep reading it. Read start button. And that's the only thing I'm going to do. So it's going to read again. It's going to check again. If it's not pressed, well, then I'm going to read it again and keep going round and round in this circle until it's pressed. Now, once it is pressed, then I can start counting down. So maybe I'll put a comment here, start counting down, and so on. So this one's a little bit more complicated. There'll be more, and you just build it up step by step. So don't worry. I think in the exam, what you need to do is keep cool and just think about the different steps that are required to do the different things that the user or the client brief requires. So you will build this up. As you can see, I'm kind of filling things as I go along. I will make mistakes. I'll forget things. So pseudocode is easy to use because you can just type in, go back, make some changes as you're typing it and making it clear. Once you have these things, and this is not complete, obviously, but once you have these things, as you can see, it's a lot simpler to transfer this into some kind of real code. So that will be the next step that you want to do. But before that, we still have a few more things that we want to do, which is drawing the block diagram and the circuit diagram. So we've got the pseudocode here in the example. So remember as well, for highest marks, write or include the unexpected events in the program design as well. Okay, for a block diagram, you've got the controller in the middle. Write in what the switches or the input devices are on the left. You don't have to do it on the left, but it's easier to see. And then on the right will be the output devices. So LEDs, buzzers, things like that. Inputs and outputs there, block diagram. Next thing is the circuit diagram. Remember, you have to draw the circuit diagram from memory. So go back and practice and keep drawing it. You have to get this right from memory so that you can build it correctly as well. Once you've done that, those are the main things really that you need to put in for activity 3. If you've done any more flow charts maybe, or if you've written down or drawn something to help you think, you should consider also scanning that and putting that in if it's something hand-drawn, so that the more stuff you put in, there will be more evidence for the examiner to give you some marks about that. Once you finish that, you're ready to move to activity 4.